Buenos días a todos. Hello, good morning everyone. Como conferencia final del proyecto europeo MANDALA. Voy a proceder en inglés porque toda la sesión va a ser así. Espero que no sea inconveniente. Trataremos de hacerlo lo mejor posible para que así se nos entienda, pero tenemos aquí a los socios del proyecto europeo de diferentes nacionalidades y, por tanto, por deferencia a ellos, vamos a hacerlo así, ¿no? We are going to continue talking in English because we have here on board our European partners coming from 5 different countries. Then, of course, we are going to continue in English during all this event, all this conference. Thank you for coming. Sorry for the inconvenience with the room, because we know that it's quite difficult to come here upstairs in this pavilion 3, but we are trying to do our best to have the full room to continue with this event. Then MANDALA, this very nice acronym, this very nice name to represent a project, an illusion, a challenging project that we are running. We are most close to the end of this fantastic project together with these 11 partners. Companies, SMEs, industries, RTOs and clusters as well that later we're going to introduce. And the future of the multi-layer packaging that we represented with the state-of-the-art technologies and materials. Then I would like to introduce and give the floor to our project officer, Pilar Llorente, coming from the European Commission. Thank you, Pilar.
Buenos días a todos. Estoy encantada de estar aquí. Good morning, everyone. I am delighted to be here today in this Mandala and Future of Packaging event. So my name is Pilar Llorente. I'm a project officer from Circular Bio-Based Europe Joint Undertaking, previously BBI, Bio-Based Industries Joint Undertaking. I'm just giving you a very short introductory words. And I would like to start by very briefly recalling what is CBE-JU, as it is a relatively new joint undertaking. It is a 2 billion public-private partnership. The public partner is the European Commission, and the private partner is a group of bio-based industries companies. And we are working for the deployment and advancement of sustainable bio-based industries. We are building on the work on the success of the BBI-EU, that you know well, who was in place from 2014 to 2020, and we will be working within the framework of the Horizon Europe, you know, the framework research and innovation program of the European Commission from 21 to 2031. And of course, among our objectives, it is to contribute to this European Green Deal framework for a sustainable economy. So let me just tell you a few words on the main key aspects of the CBE-JU. So we aim at contributing to the 2030 climate targets by promoting this transition from a fossil-based economy to a bio-based one and reducing CO2 emissions, contributing to a more sustainable industries. We are also aiming at improving the sustainability and circularity of the production and consumption systems. With sustainability, we mean both the sourcing of sustainable feedstock, the processing, efficient use of natural resources, energy, land, and water. And the circularity, we aimed at improving the end of life of products, making them recyclable, biodegradable, or reusable. We are aiming, as I said, to facilitate this transition to the bio-based economy by using only sustainably and locally sourced biomass, all types of biomass, side streams from agriculture, from forestry, organic municipal solid waste, aquatic biomass, all types of biomass that can be used to replace the fossil-based resources. And thereby, we are aiming at deploying, not only developing the research, but also deploying it in Europe and bringing also the socioeconomic impacts to Europe and to promoting regional development. So I will not go into the detail, just a few words on the general objectives. First, it is to accelerate the innovation process in the bio-based industries by gathering all together all the important actors, companies, research, community, and working all across the value chain, deploying multidisciplinary solutions. Second objective is to accelerate the market deployment of the existing bio-based solution, to facilitate the market uptake and to reduce the investment risks. And last but not least, there is a very strong emphasis on ensuring a high level of environmental sustainability and circularity of all the technologies and products developed. Very briefly, how do we do this? By funding projects, research and innovation, collaborative projects throughout different technology readiness level. We fund research and innovation actions from TRL 3 to 5. This means the development, testing, and validation of technologies. We also fund innovation actions from TRLs 6 to 8. This is more the integration of the systems, the scale-up and the demonstration of the technologies. And within the innovation actions, there are special type of projects called flagships, which are first of their kind biorefineries in Europe. We also support some non-technological coordination and support actions to support the deployment of the bio-based industries in Europe. Very briefly, as I said, CBE-JU is the continuation of BBI, so we build on the work done so far. 142 projects funded, among them Mandala, which we are talking about today, with more than 1,000 beneficiaries, as you can see in the chart very briefly. Great participation of small and medium enterprises, but also 30% of university and research centers involved, and nearly 40 countries in all the projects. So, but let's go now to the point. We are here to talk about Mandala and to the future of packaging. So what is CBE-JU doing in this field? In general, CBE is supporting the development of bio-based materials, packaging materials and others that have a very good performance, that keep all the properties that are needed for their applications, while at the same time improving their sustainability and circularity by making an efficient use of resources and developing solutions with an improved end of life. Some examples of the research and innovation activities that are being funded currently under the call 2022 are, for example, high-performance bio-based polymers and materials that meet demanding functional requirements. So these polymers that we need for packaging, textile, automotive, and that have certain mechanical, chemical properties that need to be preserved while using also bio-based materials. We have some areas of research as well in sustainable bio-based coatings, binders, barrier, and adhesives to improve the circularity and the end of life of products, just as Mandala is doing, using adhesives that don't need aggressive solvents then to separate the components of the packaging. And we are aiming at developing circular by design products, whether they are multi-layer, multi-material products that are designed in a way that facilitates their subsequent recycling and reuse. And in this context, you can see, or you will see, the Mandala, the BBI-JU projects is really an excellent example that encompasses all these features. So by developing a multi-layer packaging that can be easily delaminated and recycled, and also by using this eco-designed and adhesives that allow the recycling without the using of aggressive solvents, among many other characteristics. But I won't go much more into the detail, because for that we have our experts of the consortium. These were just a few words to introduce the projects. Thank you very much for your attention, and enjoy the rest of the session. Thank you.
Very nice introduction, and thank you for mentioning our project Mandala as one of the successful ideas, of course, and the concept of developing materials sustainable by design, these kind of products that we are going to have in the near future in our society. Of course, we are trying to do our best to have it. One issue, please, because probably I cut. Sorry. Okay, thank you. And after this very nice introduction about BBI, the Bio-Based Industries Program, and the projects similar to this Mandala project, I would like to make a very short introduction about this project. And of course, later we are going to have two sessions, two roundtables, together with the experts. And after these two sessions, these two roundtables, warm up questions to the experts, and finally we are going to have a coffee to discuss face-to-face in a very good atmosphere. I think it's just in this next room, okay? Then all your questions, comments are going to be very close, solved in this point, in this coffee break. Then, to understand Mandala, of course, the people familiar with European projects knows that are public publications about call for tenders open to all society in order to prepare solutions in a document to be evaluated by independent experts, to be granted with a budget in order to solve these open issues that the Commission offered to the European society. And together with different stakeholders, different entities, we try to do our best to solve this problem, these issues. This is the context of Mandala project. Then to understand this context, we know exactly the current situation in the world about the plastic recycling. As soon as we prepared this project years ago, we have this data that no more than the 14th plastics are recycled, and the 72% are not simple to be recovered. Okay, then it's really a problem. Waste is amount of tons around the world with this kind of plastics. Of course, during years, we invest money and, of course, efforts researching in how to develop plastics and packaging with multi-layer in order to have safety products, healthy products, and in order to obtain the right properties to be used by the consumers, by the people. However, these kind of plastics are very complex to be recycled. Then the first problem is this current multi-layer packaging are not very easy to recycle at the end of the life of this use. Then we need to find solutions, not only incineration or landfill. The second problem is that the available biological waste treatment process are not efficient or suitable for compostable bio-based packaging. And the third problem is the lack of eco-design and decision-making on reroute applied to packaging. We need to think in this concept of intrinsic recyclable materials and solutions for the packaging. This is the context. Of course, the solution that we offer in Mandala project is to create a new familiar matrix of raw materials using substitutes of the fossil-based materials with bio-based materials. And of course, working in an efficient recovery and separation of these materials at the end of the life of this packaging. And finally, reuse and recycling strategies in order to be included in this directive, these procedures that now are around us. Not only the directives in Europe, you know as well that now we are completely changing the Spanish directives as well. Then we try to include our results of this Mandala project in this scenario as well, in these documents and methodologies. Then in order to achieve these solutions, our project is focusing in 3 pillars. The first one is eco-design. The second, and one of the key points of our project, is to develop this dual functionality adhesive that later we are going to know better in detail. easy to split, and even to have this property that is barrier properties for this kind of packaging, mainly for industries of cosmetic, food, and pharma. And the third pillar is demonstrate the valorization of these recovered materials, and of course the assessment in the end-of-life routes. Consortium, let me introduce in this slide our very well-balanced consortium, 11 partners coming from these 5 European countries with a complementary competence. 7 of them are industrial partners, 1 is a food industry cluster, and 4 research partners, institutes, public and private. Our project is 8 months of duration and a budget of 4.5 million euros to develop all these tasks and activities. And here you have very nice picture about all the project development, coming from the raw material, the modification of the functionality for the adhesive and these polymeric matrices, going to the manufacturing processes, and finally to the end of life and other issues like the assessment and a contribution to standards that we have yet mentioned. Coming from commercial materials, state-of-the-art materials running in the market, of course today and yesterday we can see in EMPACK this kind of materials as well. We develop in this consortium these 2 materials. First of all, in the top part, the functional additive, and in the lower part, the polymeric matrices, trying to have at least 35% of bio-based materials in the content of this formula. Lamination process, delamination process, in order to demonstrate in lab scale and in pilot scale that is possible to separate these layers of materials, demonstrating as well the recycling processes, and then going directly to different cases for industries like pharma and food. We are using as well nanotechnology, graphene mainly, in order to improve these barrier properties and even to encourage and improve the delamination processes of these materials. Then the current activities are these 3, okay, developing at least this different formula of materials based in different bio-based materials, PLA, recycled PET, and low density polyethylene, low density polyethylene. We develop as well different articles that are publishing, and it's possible to read and search, contributing to the society with this research, and even we have a patent coming from the SESIC entity to be published. Finally, we are running now the delamination and lamination tests that are, as I said, currently developed by some of the partners. And that's all. I would like to give thank you again to all the audience to be here, and we are going directly to our first roundtable that is going to be technological changes for sustainable packaging solutions. Thank you.
Welcome everyone. My name is Paula Fernandez. I'm a consulting director at PISA Projects of Innovation and a stakeholder within the Mandala project. I would like to introduce our 4 speakers. Well, I will let them introduce themselves. It's better, so you get to know them, who are the members of the Mandala Project Consortium. So maybe you can start.
Thank you, Paula. Good morning. Buenos días. My name is Horacio Salavazione. I am a permanent researcher at the CSIC, the Spanish National Research Council, sorry. And we were in charge of the first work package of the Mandala project in the development of reversible adhesive, as I will comment later on. Thank you.
Hello, can you hear me? Yeah. I'm Katrin Noverhog. I'm coming from Norner, and we are situated in the, we are the most northern country, or a participant in this project here. So I'm happy to be among the other, Southern European partners. Norner is a polymer research institute, and I am working as a principal researcher there.
Hello, buenos días, good morning everyone. My name is Milena and I'm from Cadel de Inking, and we are in charge of the delamination part of the project, so we will discuss how we do it.
Good morning, buenos dias. My name is Luca Zanetti. I'm coming from Sapci, that from 2021 was acquired by Sun Chemical Group, but I will always remember this project as Sapci. Our main involvement, because we have a long experience about the producer of polyurethane adhesive, is try to design a good adhesive that could make a right dual use properties.
So today we are going to discuss about the technological challenges of sustainable packaging solutions. And as you can see, we have here a representation of the three main pillars of the Mandala projects, which is the eco-design, the development of new functional adhesives, and the recovery of the materials. So, in your opinion, to reach a real circular economy in packaging and following Mandala approach, what are the main technological challenges that you have faced within the project? So, I don't know, Horatio, maybe you can just...
Okay. As I mentioned before, we are a research center. We do basic research. And when we were involved in Mandala, as Berta explained before, the plastic used for packaging are materials composed of many different polymer layers, each with a specific function, and all fixed together with an adhesive. So at CSIC we realized about the sometimes overlooked role of the adhesive. And our main purpose was to develop new adhesives that are reversible. That means that we develop an adhesive that behaves as such as an adhesive under the using condition, and then after use, we can, by means of an external stimulus, to broken or to alter the physical properties of the adhesives, facilitating the delamination of these multi-layer components. Okay.
That's a challenge. Yeah. So, why?
I'd like to say something, because we talk about this in this topic. The adhesive is the problem of the problem, because adhesives are designed to make lamination, and the higher lamination we have, the customer is more happy. But if you can delaminate, we are moving in the opposite side of the new legislation incoming. So the important goal of our project, from my point of view of producer of polyurethane adhesive, that we can introduce a new way of thinking and using the adhesive that is, in one side, is laminating, and in another side is delaminating. That's the important goal of the dual functionality. Otherwise, we are continuing to think about adhesive in the way we are thinking now. His only goal is to make delamination. But if you make in undelaminable duplex or triplex materials, plastic, the recovery of plastic is increasing. So this is important. The challenge for our point of view.
Yeah. So, how is it compatible with the adduct, the adhesive chosen in the project?
Which to answer this, we have to come in a technical way. So, we produce a polyurethane adhesive, but we don't sold adhesive because, in the end, we sold an intermediate that the converter use mixing the two components we sold and obtaining the adhesive. So there is one component that is the so-called NCO terminated, and the one component that is the OH terminated. The good challenge we achieved in this project at CSIC developed a molecule, a new binder, let's call, that is we could use as another second component of the adhesive. This is important. Why we choose the adhesive we go on? First of all, because there is a part of compostable material or renewable material that is, there is no problem to say it, that is the castor oil. Mm-hmm. But let's say that an adhesive weight 1 gram, 1.5, 2 grams per square meter of lamination. So this is not the adhesive that bring the renewable part. Mm-hmm. The adhesive have to bring something else. That's in this case is lamination. In this lamination, we choose an adhesive with a high level of NCO content because the more urethane linkage we form with the new additive made by CSIC, more probability of thermoreversible bond should be.
Okay. So going back to the adduct, what are the parameters to achieve this effective thermoreversible bond?
Okay. Yeah, there are several important parameters to achieve thermoreversibility. One important factor is the temperature at which let me explain before. The molecules we develop are simple organic molecules that present reversible bond in their structure. This means that this bond can be open and closed by the effects of temperature. So this temperature is very important because we need to have a new adhesive that behave as a commercial adhesive during the using of the material and lose its adhesion properties at higher temperatures, typically around 90 degrees. Another important factor is the content of these thermoreversible bonds in the adhesive layer. The higher the content of reversible bonds, the greater the effect in the properties of the adhesive. Through the project, we have demonstrated that is needed a minimal concentration of these thermoreversible bonds in order to maintain the adhesion properties during use and modify them after heating. And last but not of least importance is the cyclability. One point is delamination of a multi-layer adhesive, but from the point of view of recycling or reutilization of the adhesive, this thermoreversible bond it needs to take place many times in order to recycle or reutilize the adhesive. Through the project, we have demonstrated high cyclability with up to 20 cycles of open and closing bonding in the adhesives.
Okay. So we have the adhesive and we have the adduct, but an important part of the project is the eco-design of the materials that we're going to use. So how is the eco-design done within this project?
Okay, yes. I think you all have different opinions maybe of what eco-design is, but in the MANDALA project we have said that used eco-design to design the multi-layer structure so that it can be easy to recycle, and that is to find the right materials to use in the structure and also to design how thick the different layers should be. Because it's also important to understand that, it's not just to change the materials from what is used today to a more eco-design structure. We also have to think about the properties, because the properties should not be worse than it is. And when we talk about food packaging and pharma products, barrier properties is very important. So in Honor, we have developed a barrier calculator, and there we can put in, different type of materials that we are working on, the thicknesses, we can design the kind of structure, and then we can also decide what type of conditions this product is going to be in. The temperature is for sure important for how the barrier is. The humidity is important, and also time. So that is what we have been developed in the project, and then it has been used then to find the kind of product or materials that we are working on.
So, if I'm not mistaken, within the project there are different structures used. You've been working on different mandala products. So how do these structures behave if you put the focus on the eco-design? How do they work?
Yeah. In Mandala we have also selected materials like polyethylene, polyester, and PLA as among materials that we think is important to work on. And the good thing is that when we work with recycled materials like recycled polyethylene and recycled polyester, we see that we have been also testing and also verified in this barrier calculator that the recycled products have the same, more or less the same barrier properties as the standard products. And then when it came to PLA, which was not earlier a part of the calculator, we have also worked in project and managed to verify and that we can model PLA also in a good sense. We see that, it's also about, what you want in the end, because, with the materials we have chosen, we see and also know that if you would like to have a good oxygen barrier, then for sure, to have a high share of polyester PET is very important, because that is a good oxygen barrier. That's the same also if you want to have a good CO2 barrier. And on the other side, then if water humidity, then polyethylene or LDP is also a good material. So that is what we have been seeing, and it's all about coming to what does the product need at the end. So there is just, we can go one way, say that, okay, we can model this thickness, these materials, and we see what we get in the end. Or we can go the other way around and say that, okay, I have a product, it needs a shelf life of 8 days or 40 days or so on. So how should we build a structure to get that? So it's a very round answer, but that's the... That's good. Yeah.
So we have the adhesive, and we have the adduct, and we have the eco-design and the materials tested. But now we have to see how the thermoreversible adhesive works and if it delaminates correctly. So maybe Milena, you can tell us how the delamination is produced at pilot scale.
Okay, to understand better how it works, I will explain a little bit how our process works. So the process is, they have different stages. So the first stage is the grinding part. So we grind the material to have it in small pieces and to can move it mechanically easier through the process. Then the second stage is thermal pretreatment. And it's very important stage because in that one we can activate the adhesive, and it consists to throw the material in a tunnel that is blowing hot air at between 100 and 120 degrees, and the residence time in the tunnel is more or less 4 minutes. Then the material goes into our delamination reactors. The delamination reactors are stirred, and they use temperature, and we use no solvent based reagents, and it's water-based, so it's super eco-friendly reagents. Then after the delamination reactor, we have a de-inking reactor to remove if the material is with some inks. And after that, we have a rinsing step where we can remove some parts of the adhesive or inks that can stay on the plastic. In the reactors, we are not using any reagents or any temperature. So when we have the material delaminated and rinsed, we have another drying step. And after that, we have the sorting to separate the different polymers. And at the final step, we have an extruder to have our product that are the pellets. So
that's amazing. So now we have the laminated material, and we can reuse it, obviously. I understand that the thermoreversible bond of the adhesives are heat stimulated, so you need to heat them. Maybe you have been working on different strategies or develop new adducts or to aid this lamination. Okay.
Yeah, let's go back to the plastic film used in packaging. There are several polymer layers stick together with an internal adhesive layer. As you know, the thermal conductivity of polymeric of polymers in general is quite low. So conventional heating in an oven can be inefficient and can take hours to break enough thermoreversible bonds in order to alter the properties of or to separate the laminates. So to tackle this problem, we incorporate in the adhesive layer radiation-absorbing nanoparticles in order to help the delamination process. We use graphene as a radiation-absorbing particles, and during Mandala we have demonstrated that this effect can be simple and remotely triggered by external radiation using an infrared lamp. That's in addition that if we use graphene, that is a 2D layer material, it also helps to improve the barrier properties of the laminates against gases like oxygen and water vapor.
So as you see, it's more than a challenge.
If we can add something, graphene also acts as a catalyst of the urethane linkage. Okay. Should be interesting.
Well, I think we are on time. If you have any questions, we are here just to solve any doubts. If not, I think maybe we can continue, and we have the coffee stop to approach these experts and ask them anything in detail. So, thank you all.
Well, a holistic approach for the design of market-driven packaging. I'm going to ask my expert panelists to come here to the stage with me. Please, Francesca, Georgios, Jorge, Adriana, and Jose Ramon.
Thank you.
Thank you. Yeah? Oh, okay. Sit here. There's no space for everyone. So I'm going to be your moderator for this session. This session is going to talk about Mandala, but with a different perspective. We are now talking about the market-oriented characteristics of the project. So we are going to start this roundtable with a small round of introduction. As we are slightly behind of the schedule, I'm going to ask you to be really brief. I really need just your name, your company, and which is your main role in the project. I think it's enough for the audience to know you better. So please, Georgios, if you would like to start.
Can you hear me?
No.
Or maybe.
I think you need to switch it.
Hello?
Yeah. No?
Hi, it's Yorgos Tsatsos from Cosmetic. We are based in Greece, in Athens, and we are manufacturers of cosmetics, food supplements, medical devices, and other pharma products. So the role in our project is to produce prototypes and validate them. Thank you.
Hello, buenos días. My name is Jorge Barriovero, and I am the responsible of packaging and preservation in Cetic Theta. Cetic Theta is a technological center where we work to support the food companies in research and innovation. And here in Mandala, we are the responsible of validating the new packaging material developed. And thank you, everybody, to be here.
Hello, I'm Francesca Braca from Arca in Italy. We are a small medium enterprises with a biological and chemical laboratory so that we can assess the end-of-life performances of the packaging, of the Mandala packaging, so especially in terms of biodegradability and compostability, but also for the sustainability, so for the life cycle approach and the impacts for environment, for economic and social aspects, and also for the health and safety aspects of these new products and processes that can affect, let's say, the workers and the workplaces.
Yes, it works. Sorry. Good morning, everybody. I'm Jose Garcia. I'm operations manager, COO at Gavi Plus, a small to medium company in Valencia.
Gavi Plus is a converting company, and we carry out the part of the lamination of the project. Well, my name is Adriana Pineda. I'm working in the R&D department in Gavi Plus and part of the project, Mandala project.
So thank you for your introductions. I think now it's really clear for the audience who we are in the table. Now I think we are really happy, we are really lucky today that we have two of the main industries that are highly reliant on multi-layer packaging here. We have the food industry represented, and we have the cosmetic and pharma industry represented here. So I would like you to share with the audience which are the special requirements we saw in the former roundtable that are really key, are crucial for your industries to have. So maybe you can start, Georgios or Jorge, as you would like.
Okay. Yeah. The requirements, let's talk about the pharma, which is more strict, it's highly regulated, so usually depending on the dosage form, if it's liquid or if it's solid, you need to have to take into account the interaction of your formula, the bulk with the content. So you need to see if it's liquid. You need to do extraction leachables and to see if the stability of the product is then affected. So you have to evaluate both the stability and the safety of the product. The safety in terms of if the ingredient that is inside is degraded or if it's stable. In the project, we were focused more on the solid dosage forms, blisters, and the main focus is to have the correct barrier properties to preserve accordingly the product. And yeah, that's...
Okay, thank you, Georgios. And what about for the food industry, Jorge?
For the food industry, for the food industry, we selected the food product at the beginning of the project. So we have working with many products, ready-to-eat product, ready-to-cook, fresh meat, cured meat. So I mean, each product require or has different requirements. So, for example, if we work with fresh fruits and vegetables, maybe we don't need high barrier requirements. Maybe the permeability in this case is not important. Even when sometimes we need to microperforate these kind of films to avoid high concentration of CO2 or extremely concentration of oxygen. But in this case, in the case of the selected product for Mandala, we need high barrier frames to maintain the modified atmosphere, because we use high CO2 concentration or maybe absence of oxygen. So to maintain it, the main requirement is the barrier properties, as it was explained in the previous round table. So in my opinion, this is the most important property, but there are more. For example, transparency is important, the thermal resistance, and mechanical properties, because it's important that this kind of materials works in the industry. So in general, the most important is the barrier properties.
Yeah. So I understand you have a really special requirements, you have a special characteristics that are needed for the products in order to be delivered safe, in a safe way to the market. Are there any alternative to multi-layer packaging really on the market at this stage? Or do you really think that, for example, Mandala project is going to move forward this kind of packaging sector?
Are you talking about a sustainable alternative
to
the petrol-based? Yeah. In my opinion, there are no a solution in the market, because it's difficult to reach this kind of properties with this kind of sustainable solution. But Mandala project, I think is one of the best solutions, because you can use traditional materials, complex materials, and you can recycle this kind of materials.
So the challenge is in the recycling part, I think.
Yeah,
sometimes. And when we talk about the market, I think it's really important to talk about also to the other side of the coin, to the consumer perspective. Have the consumer has been taken into account within the Mandala project, which are the I don't know, the reports you have done, the surveys? So I don't know if you have taken into account the consumer perception of this.
Yeah, the consumer is very important for us. It's very important for the project, and yes, we have taken we have a platform, a Mundo Support platform, where we can interact with it's an online platform, and we can interact with more than 3,000 households. So in this case, we have launched 2 surveys. One of them at the beginning of the project, to know their opinion and knowledge about the objectives of the project, and the other one at the end of the project, when the objective was to know about their opinion and knowledge about the results. Okay. So what is their opinion about Mandala solution? So they are very interested. For example, in the last survey, we explained everything about the 3 prototypes developed in Mandala project, and for example, we said that this kind of products maybe it's possible to have an special opacity. It's not totally transparent, and maybe the texture is rough or something like that, and they have no problem with this kind of problem, for example. So, and for example, if they are able or they are willing to assume a reduction in the shelf life of their product.
If the product is recyclable, for example, if the product is sustainable, so for the consumer it's key to have sustainable packaging in the future.
Exactly. So the problem, I think, is the price. The price, they are very worried with the price. So
price is really important for the consumer, I think.
Not everybody is able is willing to pay more. For example, in general, only 30% of the people are willing to pay more. They are sure, but 50% they are not sure. And in general, more than 50% they are able to pay no more than 0.5 euros, per pack. So it's general information. So they are very worried with the price.
So they are sustainable. They are sustainable, but they want the companies to be sustainable for them, I think.
Yeah.
So I think this is going to be one of the conclusions. But I would like now to go to the right side of the round table now, because as we saw, the recyclability is going to be key for this sustainable packaging in the future. So I would like just Gabi Plus, for example, just to explain how your process is going to make a difference in the recycling process.
Yeah, I would like to mention that I've been last week, for example, in the CBE-JU in Germany, which is the most important in the world every 3 years. So all the main word or the main message you can see there is that the sustainability is the key word, and behind sustainability there is the recycling. So for the multi-layer structures, for me, the Mandala project has this special focus on the delamination and to use different materials with different properties, and at the same time we let's say, I don't know how to say it. If we want to make sustainability and recycling, first of all, we have to delaminate the materials. So this allows us to use different materials with different properties.
It's a way to simplify the structure.
Yes, it is.
So and just about you said at the beginning of the roundtable that you are an SME, and I was a bit curious because I think for the European Commission and especially for the CBE-JU, it's really important the role of the SMEs in the program. So could you share with the audience which are your experience working in this kind of projects, what you have brought away from this process?
Yeah. So first of all, I have to say that we are very proud to be here because it's surrounded by all these kind of companies, laboratories, scientists, researchers, and in the case of Gabi Plus, we started with the first European project in 2019. Okay. It means more than 10 years ago, with the LAT-STARK project, and from then to now we have been involved in 5 projects more. As a operation manager and also one of the owners of the company, the European Commission and all this, it's a very important help, and increases and helps us to be in the market, to be in as a reference in Europe, and it is, I would say, it is crucial. It's very important.
So collaboration is completely key for your company to remain competitive in the end.
All right, that's it.
Okay. And now I think it's time we have talked about a lot about recyclability, and we have now here Francesca, which is one of the experts in terms of certification and recyclability. Which are the certification that exists nowadays, and how Mandala is performing on this?
Yes, well, we can focus for the end-of-life pathway for several products for the compostability. The compostability means that the final user, the consumers, can put its waste, its packaging, together with the organic waste from his home, and then collected to the municipality for the industrial pilot plant. So in Mandala, we have already validated our formulation for the compostability, the industrial compostability, and the performance were perfect, in compliance with the requirements, but also for many other protocols. Okay. And for this, we have verified for the marine end of life, that is not the allowance to put in marine the formulation or the packaging, but it is not, let's say, a packaging waste that can be present in the marine environment till 100 years. And also we are just running the test for the soil, for example, as another type of final, let's say, end of life. And the test is still running, so we have not the final results, but it's very interesting. But also for the home compostability, which is another let's say, possible pathway for the packaging in the household let's say, composting plant. But in addition, I'd like to answer also to the previous question for Carlos, also from my side, since thanks to the European project, for example, my company, ARCA, has been recognized by TÜV Austria as a recognized laboratory. We achieved all the certification during the European project researches.
So it's a way to grow.
Yeah. Yeah, so we increase a lot of the knowledge, the experience, also the equipment, the capability for the assessing of these final end-of-life scenarios. So it's
I don't
very,
know
very
if
interesting.
Jorge or George would like to share also your experience working in European projects, because I think you have also a great experience. So
Yes. I have. I don't know how many years, maybe 10 years, more than 10 years working in European projects. Yeah, my experience is very good because I have working in European projects more than the other kind of projects, so I can't compare with other kind of projects because I am very focused in this project. But in my opinion, in general, everything everything is very clear. The objectives are very clear, and the consortium works very well in general. And
it's a way to expand your network, for example.
Yeah, and this always is an opportunity when you are, for example, in this kind of scenarios or with kind of events or in the consortium meetings. Everything is an opportunity to show your work.
Mm-hmm.
So I'm very happy to work in European projects in general.
Okay. I think we ran out of time, so I think as a conclusion, we are in the need of sustainable packaging, not only for the industry, but also from the point of view of the consumer. Recyclability is going to be key, and I think Mandala project is performing quite well, as you mentioned. So I think that's everything from our side. Now, see if we have any question from the audience. We are here. So if not, we are going to go for the wrap-up session, and we can solve the question in the networking lunch.